Hi there. For this video, we'll be evaluating logarithms. In the previous video, we had some examples on logarithms, but I think that those examples are not enough. So here are some more logarithm examples, especially on how to evaluate logarithms. So let's start with this first set of examples. Let's have here the logarithm of 27 with respect to base 3, the logarithm of 1 over 25 with respect to base 5. Let's fix this one. And the third one is the logarithm of 3 with respect to base 9. So how do we determine these logarithms? For the first one, note that 3 times 3 times 3 is equal to 27. So 3 cubed, or 3 times 3 times 3 is simply 3 cubed. Therefore, the outcome for this one will be 3. For the next one, 1 over 25. Note that 1 over 25 can be written as 1 over 5 squared. And 1 over 5 squared can be written as 5 raised to negative 2. Therefore, we have found the exponent, so this must be negative 2. Last one. Now, this last one is quite tricky, but note that 3 is equal to the square root of 9. And square root of 9 is equal to 9 raised to 1/2. So 9 out here matches the base out here. Therefore, we can conclude that the logarithm of 3 with respect to base 9 must be, the exponent here is 1/2. So we have here 1/2. And those are the answers for our first set of logarithms. Let's have our second set of examples. We have here ln of e squared, ln of square root of e, or rather cube root of e, and ln of 1 over e. Now for this one, just recall that ln of, say, x is simply equal to the logarithm of x with respect to base e, wherein e is the Euler's number, or the Euler's constant. With that in mind, let's move this one out here. Then, for our first example, this is simply the logarithm of e squared with respect to e. And note that by another property of exponents, the outcome here is simply this exponent out here. So we have here 2. For the next one, this one will be equal to logarithm of the cube root of e with respect to base e. Note that the cube root of e is equal to e raised to 1 over 3. Therefore, the answer here is 1 over 3. Last one. For this last one, just note that 1 over e is equal to e raised to negative 1. So, this is simply equal to, the exponent here is negative 1. So, we have here negative 1. So, observe that here in the last example, I didn't need to write ln anymore in the form of this form out here, since as time goes by and as you encounter more natural logarithm, this part out here isn't really essential anymore. Let's have our third set of examples. Let's have the logarithm of the cube root of 100, the logarithm of 1000, and the logarithm of 0.01. Now note that if the index is missing, that simply means that the base out here must be 10. And now we can solve this one. Note first that the cube root of 100 can be written as 100 raised to 1 over 3. And 100 can be written as 10 squared. So, in total, combining the exponents, this is simply 10 raised to 2 over 3. Therefore, since we have already found the exponent, the outcome for this logarithm is 2 over 3. For the next one, note that 1000 out here is equal to 10 times 10 times 10, or 10 cubed. So, the outcome for this logarithm is 3. Just take note that if you're having a hard time in following these examples, you may check out the previous video, as in that video I discussed the basic idea behind logarithms, its definition, its properties, its laws, and so on. For the last example, note that 0.01 in fractions is actually 1 over 100. So how did that happen? Note that we can write this as 0.01 over 1. Then we move the decimal places on the numerator twice to make it a whole number, and move it twice as well on the denominator. So this becomes 1 over 100, like that. So you may check out my video on converting decimals to fractions for an in-depth guide on this one. And furthermore, 1 over 100 is equal to 1 over 10 squared. And 1 over 10 squared, so let's move this one. 1 over 10 squared is actually equal to 10 raised to negative 2. Therefore, the outcome for this one is negative 2. Let's have this fourth set of examples. Let's have the logarithm of 1 with respect to 35, the logarithm of 1, and ln of 1. Now, for this one, we don't really need any complicated solutions, since we have a certain property wherein if we have the logarithm of 1 with respect to base a, wherein a is not equal to 1, the outcome for this one is simply 0. So applying this to what we have, the outcome for these are simply 0, 0, and 0. So take note of this property out here. It's very helpful. For our fifth example, or fifth set of examples, we have the logarithm of 10, ln of e, and the logarithm of 2 with respect to base 2. Now note that for this one, we simply take note of the property that if we have the logarithm of a with respect to base a, so as you can see, the bases, or the base out here, is similar to this one out here, then the outcome for this one is simply 1. So note that in the first example, since the index is missing, we simply know that this must be 10. So the base is similar to this one out here. Therefore, the outcome for this first logarithm is 1. As for the second one, note that ln is the same as the logarithm of base e. Therefore, this one is simply 1. For the last one, since this one is 2 and this one is 2, therefore, by the property that we had, this is simply 1. So pretty straightforward. Let's go on to our sixth example, or sixth set of examples. We have the logarithm of 10 out here raised to 10. Next, we have ln of e raised to e. And lastly, we have the logarithm of 5 raised to 5 with respect to base 5. So how do we solve this one? Take note that we have a property of logarithms wherein if we have the logarithm of a raised to n with respect to base a, this one is simply equal to the exponent out here, which is n. So technically, what happens is like we cancel this logarithm and the base of the exponent out here, since exponential and logarithms are like inverses of one another. Therefore, the outcome for these examples are simply the exponents out here. Since for the first one, we know that since the base is missing, this is simply 10. ln out here is simply logarithm with respect to base e. And on the last one, we've got the base 5 out here and 5 out here. Therefore, the outcome here is simply 10, e, and 5. Let's go on to our final set of exercises, or examples rather. Let's have 7 raised to the logarithm of 8 with respect to base 7. 10 raised to the logarithm of 11, and e raised to the ln of 71. So observe that if we try to simplify these logarithms first, it will take us a lot of time, since it's not that easy, since the base and the basis of these logarithms out here, so this one for this one it's e, and the numbers out here are hard to simplify. Since for 8, we can write this as 2 cubed, but 2 and 7 does not match. So it's not really that easy, but fortunately, we have a property that says a raised to the logarithm of n with respect to base a is simply the exponent out here, which is n. So technically, similar to the one a while ago, it's like this one out here cancels out as long as the bases are the same. Therefore, the outcome for these are simply 8, 11, and 71, since we know that the bases here are the same. 10 out here is the same as this one, and ln is logarithm of with respect to base e, so it's the same as this one. Therefore, the outcome here is simply 8, 11, and 71. And those are the answers for our examples. But of course, we will have some exercises. So these exercises are useful for you to and practice your skills on logarithms much more. And note that these exercises are quite fun to do and a bit challenging, so don't hesitate to try these exercises. So we first got the logarithm of 1 over 2 square root of 2 with respect to base 4. For the second one, we have the logarithm of 10 times the cube root of 10. And for the third one, this one is interesting. We have e raised to the ln of e raised to ln e. So let's fix this parenthesis out here. So here are our exercises. So please don't hesitate to try these exercises out and comment down below your answers and solutions to these exercises. So that's it. I hope you enjoyed this video and I hope you learned a lot from this one. So that's it, and that is all for this video.